Now after generating the mesh, you can see the mesh quality or how the mesh look like in the different regions. And as you can see here, the boundary layer is resolved with a very fine mesh, and also we have the very highly resolved wake region. So the simulation on this mesh will give us the very high quality results like the drag coefficient and the lift coefficient, and as well as the very highly resolved flow in the wake region. The second thing is to check the mesh quality, and then third is the mesh statistics, that how many number of nodes are there. The important parameters for check is the mesh quality, are the skewness and the aspect ratio. So maximum skewness should not be more than the 0.9 or 0.93, and in this case it's the 0.78. In maybe in the mesh we have just created, maybe we have slightly different values, and the maximum aspect ratio is the 3200, and number of nodes are 21,940. So to see or to look at the mesh quality and the mesh statistics, click on the mesh and then go to the quality, and from quality in the mesh matrix select the, let's say, the aspect ratio, and this comes out to be the 4441. So maybe if you change the sizing, the ratio of the growth rate, you can change the aspect ratio in the cells which are in the boundary layer or in the wake region. And just remember that for the very high aspect ratios cells, for example, any value which is higher than the 1000 and less than the 10,000, you should or you must select the double precision solver for the higher solution accuracy. And the second mesh matrix, which is very important from the CFD point of view, is the skewness. Its quality should be less than the 0.9 or 0.93. In this case we had the 0.78, and also we have here same 0.78, and you can see, you can locate where we are getting the very low quality mesh. So you can click on these bars. So this will give you idea that we are getting the low quality mesh in the leading edge part, and this is because of the domain shape and the aerofoil shape, because the aerofoil is sort of the elliptical shape and the domain is of the circular. So if you change the shape of the domain to the from the circular shape to the elliptical shape, you can improve the mesh quality. And secondly, you can also subdivide the domain maybe at some location near to the aerofoil, and in a similar pattern we get again the C mesh, but this time we should be getting the two zones. So in the one zone we can have the very much control on the mesh distribution, and then we can open the mesh in the outer part. In this way also we can increase the mesh quality. And last option is to use the ICM CFD, because in ICM CFD these things are very easy to control. We can subdivide the domain into the many zones, different parts with a one click only. But in the Ansys meshing you have to go back to the design modeler to make the changes in the geometry. So ICM CFD is recommended for the high quality meshes and the best quality or the highly accurate results. So you should be going for the ICM CFD. Anyhow, and then the next thing is to check the mesh statistics. So here number of nodes are 19,000, and the slide they are 21,000. So maybe slightly we have some variation in the number of nodes or division on the edge sizing, but slightly different, but almost the values are same. So we are getting the number of nodes are 90,520. So with this one, the last topic, we are now just finishing the tutorial on the Ansys meshing, and also I have included one part that how you can output the mesh for the Fluent, which is very straightforward. But for the CFX, because the CFX is a 3D solver, so this will not work. It will not work with 2D meshes. So we have to apply some methods to get the CFX working. So in the next lecture, I will discuss those methods, that how you can export the mesh and import the mesh in the Fluent and also in the CFX, because after this workshop we will solve this aerofoil in the Fluent and as well as in the CFX.